I'm going to work through two questions today, one from Daniel, one from Ravi. Might have a bit of break in between because they're totally different kinds of questions. The general solution one. Because a lot of people ask me about general solution. This one in particular is the last question in last year's 3-unit paper. Okay, last question. So of course you would expect it to have some meat to it, okay? But as I've been saying, and as you'll see, okay, this is a max mean question. When you have a look at the kind of function it is, like it's not even a trig or exponential or log function. This is a 2-unit question. It's a 2-unit question, okay? So I'm not going to solve both parts to it. This result is what you have to prove in part 1 of this question. There's like a piece of, I don't know what it is. It's a rectangle of nondescript substance, and then you have to construct some metal strips across it, blah, blah, blah. Anyway, I think there's 2 strips, and you want their total length, and eventually you'll land on this expression, okay, which is not that hard, 2 marks. I don't think it was that big a deal, right? Yeah, okay. The real fun starts when you want to solve for when you get the shortest. Yeah, shortest. Find the dimensions of the rectangle which will minimize the total length L. Okay, so it's a max mean question. Okay, I'm going to pass that. Now, it's a max mean question, so the first thing that your first instinct is differentiate. Okay, so let's do it. So dl on dx. Okay, it starts off pretty easy. 1, and then it drops you right in the deep end, right? Okay, so just sort of screw this up, and I would advise you do this kind of thing as well, right? This is a quotient. You can't, write it another way that's not a quotient. But the numerator is complex enough that if I'm trying to do this in my head, I can imagine myself like forgetting to differentiate the inside or the outside of something, okay? So just off on the side here, another color. Let's just differentiate the numerator so that when I go ahead and do chain rule, do my VU dash, blah, 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 I'll get that right, okay? So if I want to differentiate this, I'm going to need to use chain rule in the numerator, so I might as well put it to the power of a half, okay? So this is, sorry, that's an x. This is really what I'm working with, okay? So rehearse it with me. Chain rule means do the outside, then do the inside, or whichever order, doesn't matter because multiplication order doesn't matter. So half out the front, x plus 1, power reduces by 1, that's the outside, so now I've got to do the inside, and the derivative of the inside is just, good. Okay, by the way, I know it caused some consternation when it was first introduced, maybe in like year 9 or something. You're like, what do you mean a dot multiplication? That's confusing. Why not just use a cross? Well, because this is why. Because I've got x's flying around everywhere. Okay, so you might like to get in the habit of using dots in multiplication. It's actually not that bad an idea. Dotty.
Wait, you know the dot in the middle, right? Is that meant to be decimal and the dot at the bottom?
Okay, so 3, let me think about it. Yeah, okay. So really, that should be read as 3 times 4. The reason why we're used to thinking, okay, that's 3.4, which I really, if I wanted to write it, it should be in the middle, is because putting a dot in the middle in Microsoft Word is a royal pain. So everyone just puts a period, okay? But that's actually multiplication, okay? So anyway. Multiply, so what have I got? This guy's going to go on the denominator, and that half's going to turn that into 2. Question?
Are you differentiating that?
Okay, so have a look. It even says what I'm differentiating, right? I'm differentiating the numerator because it's messy enough that when I launch into quotient rule, I don't want to have to keep it all up in my head. Okay, the more stuff that's up here, the harder it is to make sure you get it accurate. I want to minimize all the silly errors and that kind of thing. Okay, so this would go under the heading of exam technique. Okay, because silly errors, like you'll go through all the same steps, you'll just forget something by accident. Okay. Anyway, 2x cubed all over. Okay, happy with that? Is that okay? Good. So this is going to be if this is u and v, this is my u dash, if you like. So I'm going to pull that out in a second. Okay, let's launch into the quotient rule. Okay, v u dash. So if I've got my x on the bottom here and I multiply that by u dash, it's just going to turn into 2x to the 4, right? All over that, okay? VU dash minus UV dash, okay? What's V dash? It's just 1. So U is just going to hang out on its own, okay? VU dash minus UV dash all over V squared, which is x squared. Okay, there you go. So there's my derivative, and I could sort of start working on it now, but any suggestions? What should I do with this? Okay, I've sort of got two choices, okay? I can either put it all over x squared, or I could actually turn it into 3 different pieces. One, leave that on its own. See, this x squared divides really nicely into this, right? So I can divide through and then put this x squared on here, okay? Now, I don't know if it matters all that much which way you go. I went one particular way. I'm just thinking about which is the easiest for you.
Would it be easier to cross over a common denominator?
It won't matter in the end. It won't matter in the end.
If you make it equal to 0, it's
Again, it won't matter. Partly because as well, if I put it all over x squared, right, then I'm going to eliminate x equals 0 as a solution, but x equals 0 is not a solution anyway. But let's go ahead and do it. So if I'm going to put everything on top of x squared, that one's going to turn into an x squared, right? So then I'll have this weirdo fraction here. And rather than draw a, an enormous fraction line, I'm going to just put it as that times 1 over x squared.